Hi students, welcome to all of you to this concepts and snippets session. Today we are going to discuss one of the fundamental chapters in chemistry, chemical bonding. Except noble gases, all other atoms of elements undergo chemical bonding to attain stability. Why noble gases are chemically inert or stable? Because they have an arrangement of 8 electrons in the outermost shell except helium. Helium has 2 electrons because it has the outermost shell is K shell and its maximum capacity is 2. Except helium, all other noble gases have 8 electrons in the valence shell, an arrangement called octet. So, the first theory of chemical bonding is the force that binds the particles together in a compound. I repeat, chemical bond is the force that binds particles together in a compound. Okay, it was Lewis and Cossel put forward the first theory of chemical bonding called electronic theory of chemical bonding, or simply the octet rule. So let us see the octet rule or the electronic theory of chemical bonding. According to W.A. Cossel and G.N. Lewis, atoms of elements complete their octet either by losing or by gaining or by mutual sharing of electrons in the valence shell, so that the valence shell has 8 electrons in the outermost shell, an arrangement called octet. Once 8 electrons are present in the valence shell, the element gets stability. That is the secret of inertness of noble gases. Okay. So, electronic theory of chemical bonding or the octet rule. It says what? Atoms of elements undergo chemical combination or chemical bonding by losing or by gaining or by mutual sharing of one or more electrons, in the valence shell. Okay, by sharing one or more electrons in the valence shell, that is the outermost shell, valence shell, to complete their octet. That's why the rule is called octet rule. Octet means what? Octet means an arrangement of 8 electrons, in the outermost shell. Okay, so it's very simple. It was G.N. Lewis who proposed the dot formula. The valence electrons are shown as dots around the symbol. Let us see the Lewis dot formula of elements of second period. That is starting from lithium. Outermost shell of lithium has 1 electron. Beryllium has 2 electrons. Boron has 3 electrons. And carbon has 4 electrons. Nitrogen has 5 electrons. You see, oxygen has 6 electrons. Fluorine has 7 electrons. Okay, 1 electron shortage of octet. And neon, the last element of the second period, has a completely filled octet, so inert. So all these elements try to complete their octet, so they are chemically stable. So in this process, elements up to 3 electrons in the valence shell lose electrons to complete their octet, whereas elements with more than 3, from 4 up to 7, okay, So 4, 5 and up to 6 electron, they undergo sharing, whereas elements of 7th period halogens with 1 electron, they readily accept 1 electron, okay, and complete their octet. So elements of group 1, group 2 and group 3 readily lose electron, while elements of group 16 and 17, oxygen family and halogen family, readily gain electron, whereas elements with the 4, 5 electrons in the valence shell mainly undergo chemical combination by mutual sharing. The aim is to complete the octet. Clear now? The valence, the group valence of an electron, you see, this is group 1, group 2, this is group number. Group 1, group 2, group 13, group 14, 15, 16, 17 and 18. So, the group valency is either the number of valence electrons, either the number of dots, or 8 minus the number of electrons, 8 minus the number of electrons in the valence shell. Okay. So, this simple theory explains very clearly why noble gases are inert while atoms of other elements are reactive. Remember, elements up to 3 electrons in the valence shell lose. Elements with the 6 and 7 electron in the outermost shell gain. And you know the bond is called ionic bond. While the chemical bond formed by mutual sharing of electron pairs is called covalent bond. Clear now? Now, let us do a simple question. Give the Lewis dot formula of carbon dioxide, a covalent molecule, because carbon has 4 electrons in the outermost shell. So, carbon with 4 electrons in the outermost shell. So, it needs 4 more electrons to complete the octet. So, in this process, it shares, you see, 2 electron pairs with 1 oxygen, and also it shares 2 electron pairs with the other oxygen. Thus, you see, both carbon and oxygen have completely filled octet. You see, around carbon you have 8 electrons, and around the oxygen, around both oxygen you have 8 electron. Thus, both the atoms involved in bonding complete their octet. So, you can see in carbon dioxide, 2 pairs of electrons are shared, and with the other oxygen also 2 electron pairs are shared, and both oxygen atoms are completing the octet. Clear, no? So, otherwise you can represent like this also. When 2 electron pairs are shared, we show by a double bond. Here also there is a double bond, and the other electrons are not involved in bonding. We call them as lone pairs. Hope it is clear? Yes. I'll be coming with more questions from this chapter in our next concepts and snippets session. Thank you.